It's loud. Yeah, so here's the project itself, the number guess game. Read through this. Okay, everything that I'm about to discuss is discussed here with sample code, so you could go and grab code from here. So today we'll talk about the input function. We'll talk about how it is that we can force the input function to actually, in the end, give us an int in a way that will not crash our code. And then we'll have to talk about random number generation, how it is that we can determine how long some process took. And then I suppose, well, this is the part that you want to keep an eye on as you work. Here are the project instructions. I will talk about these over the next couple of days, but here are the requirements for this particular project. And I take all of this quite seriously. When I run your code to give it a grade, I will verify that it does all of this. I will probably create a rubric so I can have boxes that I can check off to make sure that your function does what it's supposed to do. All right, so know that that's there. And then the question, of course, is, well, what is this? Okay. Um, what is this game that you're supposed to write? Well, I tell you what, I'll run my version of it. So I am here at Visual Studio Code, where typically I write my code. It's quite a nice tool. So I just executed the program. So here's what it does. Okay. Well, first of all, it's like there are two users for the program. The first user sets the game up, and then the second user actually plays the game. Okay? So the first user who sets the game up has to set bounds. Okay, a lower bound and an upper bound, and then a random number will be generated within those bounds by the program, and then the second user, the player, will have to guess what that number is, together with a little guidance about too big, too small. So you tell me. Well, no, I'll tell you. Your code should be robust. Okay, and what I mean by robust is this: is that I should be unable to crash it no matter what I put in. So, for instance, if your code were to ask for a lower bound, which is an integer, right? That's what it wants. That's what it could use. If you were to type in something that could not be an integer like DOG, the code should not crash. It just should not. I will do that test for sure when I run your code. So notice what it said. It can't convert that to an int. And try again. So, and put the lower bound again. And if I were to try something else that's ridiculous, it would do the same. Until finally I put in something that can be converted to an int. Okay, so now we have the lower bound, and now we want the upper bound. And the upper bound as well should not crash if you type in something ridiculous. It cannot be an integer. But it should also not crash or otherwise misbehave if I were to type in something that is actually smaller than the lower bound. The upper bound needs to be larger than the lower bound, so this kind of case should be handled. And there it is. Lower bound must be less than upper bound, so choose the bounds. Again, it should be just the first bound should be bound, not bound. So let's actually choose something that is acceptable. So how about 1 and 12? And notice what it just did. It cleared the screen, cleared the console out. I'll show you how to do that. And this is now the second user, the player of the game. So we have a lower bound, an upper bound of 1 and 12. We also report the number of guesses that have been made. All right, give me a guess. Let's just play the game. 8. That's too high. Give me another guess. 6. That's too high. Say again. What? 2. That's too low. That's too low. I think I know what it is. There's actually a good question here. The good question is what's sort of the best strategy? This is basically a search type question. Okay, so there's an object here that we wish to find, right? And we know the range that it's in. And the best strategy, I think, in a case like this, or at least an example of the best kind of strategy, is to always go halfway. We'll actually do later on in the list chapter, I think, where we will have long lists or long data files, and we'll have to search whether a particular object is in them. That will be the way that we do it, by midpoints. But anyway, so there we go. Oops, we should be able to see all of this. So let's see. So notice what it did. Got a message. Congratulations. Elapsed time, 41.17 seconds. So of course I'll have to teach you how you do that. Okay, how you keep up with the total elapsed time. Also, the number of guesses is reported, and then this is a requirement. It asks whether you wish to play again. And if you type in yes, If you type in yes, then you'll be able to play again. So notice it cleared the screen out, and then we can start again. So this is what your code should do. So let's begin to talk about how it is that you can actually make your code do all of this. Well, let's begin to write some code together. Okay, so hop over to REPL. What we need to talk about initially, and this is all I'll do today, what we need to talk about first is the input command, which you have seen, but we need to do something with it that we did not do before, I don't think, or not all of what I'm about to show you anyway. So you remember the input command, right? So the input command will allow the user to type something into the console, and then that will be the return value of this call to the input function. I should call it a function, not a command. And then you can put a message in parentheses. That's the input. That's the argument for the input function. And then what will be output is whatever the user types in. So I can run this. Yeah, tell me your name. So here we go, Frank. And then, not very good so far because we didn't actually store the value now, did we? So we would, of course, like to store the value. I mean, what good is it to execute a function if we don't capture its return value? So let's capture its return value in a variable that I will call ANS. So I'll do it again. So once again, tell me your name. Short version, it's really Franklin, Frank. And then, oh, it's been captured. And we could do that with ANS. We can simply type ANS into the console, and then it reports back what the value is. Okay, so far so good. This is how you interact with the user. This is how you get input from the user. But there's an issue here. Okay, look at the way that the value of ANS is reported. What kind of object is that? It's a string. We know that it's a string for sure because of the presence of the quotation marks. That's how Python tells us that this is a string. However, in the number guess game, we wish the input to somehow or another become an integer. Okay, we need it to become an integer. And just to point out why it is that we have to do something to make that happen, well, let's say that I were to type in 1, 2, 3. My joke in the previous class is that this will be the name of Elon Musk's second child. You can go and look. If you don't know, you should look up the name of Elon Musk's first child. So 1, 2, 3. And then, okay, so once again, I can have the console tell me the value of ANS. Once again, it uses quotation marks, which means that this is a string, which means that I can't do the kinds of things to it that I would like to be able to do. Like I want to treat it as an integer, which means that I could add other integers to it potentially, or compare it with other integers, right? And then when I try to do that, I get an error message. Okay, so this is a problem. There's only one way to get input from the user. It's just the input function. Well, it's not quite the truth, but for us it is. And the value that comes back to us, the value that's returned, will always be a string. There isn't like some special input function that returns integers or something like that. So we have to convert it into an integer. And there is a way to do that. It's with the type conversion function that is spelled INT. So let's begin to play around with that. So I will call the INT function the type conversion to integer function. The argument will be ANS, which is that string 1, 2, 3. And then notice the output value. Okay, the output value now has no quotation marks around it, which hopefully means that it is now an int. And I tell you what, we can verify that. So let's convert ANS, which is still a string. Notice this, that it's not like I took the object and changed it into a string, but rather I generated a new object, which is like the integer version of that string, and that was the output. Okay, so if you were at this moment in time to look at ants, it's still the string, right? So a call to that function doesn't like modify the string, it creates a new object. So if I wish to capture that result, that return value, I have to use a variable assignment statement. And there's really no need here to introduce a new variable because ultimately I just need to return a value that is an integer. So I'll overwrite. Okay, so I'll take that ANS string, I'll convert it to an integer, and then the integer that results will be assigned back to ANS. And then you can see that ANS is indeed apparently an integer, and we could verify that. Remember the type function? We'll tell you the class to which an object belongs. So type ANS, int. Good. Okay, good. But there is a problem. Okay. And let me just show you what the problem would be, and I'll begin in a moment to teach you how to get around this. So let's say that you were to type in, I tell you what, I'm going to go back and change the message so it makes more sense. So tell me an int, give me an int, give me an int. So I'll run again. So give me an int. So let's say you type in something like dog, right? And then at some point along the way, we're going to want to convert that into an integer. But the problem is this, is that ANS was the string DOG. And of course, there's like no way. I mean, what sense does it make to convert the string DOG into an integer? It makes sense to convert like 1, 2, 3 into an integer, but the DOG makes no sense at all. Now, I require that your code, like I said a moment ago, that it is robust. Okay, that is that I am not able to crash it when I run your code. So there has to be a way around this, right? There has to be a way to handle this kind of case when a type conversion to int would cause the program to crash. Well, I always love to say this, what I'm about to say. There's a piece of advice that Python programmers will often give you. It's like one of those pithy bits of Python wisdom. It's not good life advice, it's terrible life advice, but it's good Python advice. And it's this: it is better to ask forgiveness than it is to ask permission. You probably heard that before. I assume that's true of other languages as well. It is better to ask forgiveness than it is to ask permission. This is not good relationship advice. Don't do that. If you think there's something that you ought not do, this is not an invitation to go do it and then just abjectly ask for forgiveness once you're done. However, with Python, you can do this. And the idea, and I'll show you the code in just a moment, the idea is this, is you can try to take the user's input and convert it into an int. And then if that's not possible, instead of crash, handle it in a particular way. Respond to that so that your program does not crash. Okay, so let me begin to show you how this could be done. And this really should go inside of a function. So we'll begin to write a function. I'll call it just simply get int because that's really what it does. And it makes use of the input function. And I tell you what, I will make this function somewhat more general. Instead of like always use the same message, let's say that the parameter for this function is the message that will be displayed when we attempt to get input. So the message can be whatever, right? Which means then potentially that this is useful in a number of places in the project you're about to do, right? You're supposed to get a lower bound, you're supposed to get an upper bound, you're supposed to get a guess. Now they're all similar in that they'll all be integers, right? But they're different in that they'll present different messages to the user. Well, this is how you could start to do that. Okay, so we'll indent line number 2 now, so it's part of the body of the function. And then instead of some fixed string that will always be displayed no matter what, let's say that we'll use the input value, whatever that is, so message. And then, here's what we need to do, okay? And I'll build this up slowly, piece by piece. What we need to do is this is literally how it will be done in Python. We need to try to convert this into an int, okay? We need to try. And there is a new keyword here, PR1, followed by a colon, followed by an indented block of code. Okay, so we need to try to convert this into an int. Okay, so here I go. I'm about to try to convert it into an int. Now, here's the logic of a try block. If Python is able to execute every line of code in the try block with no error, and by error I don't mean like the Boolean false or something. I mean literally the program crashes with the red error message in the console. If it's able to execute every line of code in the try block without an error, it does. Okay, it just goes through them. If, however, there is any line of code in the try block that would throw an error, if it were not in the try block, then we stop the try block and we skip the except block. Okay, now in this case, the except block I assume would be something like, that's not an int, or whatever precisely you want to say, but that's the idea, right? We tried to convert to an int, but apparently that would have thrown an error if it were not in the try block, so we skip to the except and we execute that. Okay? Now, of course, if we're able to do the try block, well, all is well, right? So we have the integer that we wanted. And then what presumably we would do in this case is, and I'm going to introduce the full structure of try and accept, it includes an else. What presumably we would want to do is return the answer. Now, how does else work with try and accept? Well, what Python will do again is it will try to execute the block of code under try. If it can, it of course will. And if it is able to execute everything in the try block, it will then skip to the else block if it exists and execute that. If, on the other hand, any line of code in the try block does throw an error or would throw an error, we'll do the accept block. We will not do the else block. Now, a really good question is this: is like, why not just like put the else code right under the code and try? I mean, you could logically, it's equivalent. That's dangerous, however, because the nature of a try block is that it will catch any error in any line of code. And it could be the case that somewhere in that try block you made a mistake that you did not realize you had made, like you misspelled a variable or something, or you divided by zero and you didn't mean to do that and you didn't think that was a possibility. But the try block will catch that error, and it will suppress the error message. You won't see it. And then even with that error that you did not think was possible, it will still throw you into the accept block. Okay. So the idea behind try and accept and else is that, and I didn't used to do this, is that only put into the try block those lines of code that you think might actually throw an error, preferably just one. Preferably, if you've got multiple lines of code that you might think throw errors, probably should have multiple try, except, else blocks. Okay, so let's actually see what happens when we use this. Okay, so I'm going to run. I mean, we're not done yet. This is not everything that we need it to be, but it's close. Okay, so I'm going to call the getInt function, and I'm going to send it a message to display. So, like, give me int, and then, well, let's see. Okay, so I'm now inside the function, right? This is line number 2. It awaits my input. So let's say that I type in something that can be converted to an integer, like 1, 2, 3. And then, ooh, yeah, it got returned, right? But let's try it again with something that could not be an integer. So I'll type in give me int again. So I'll type in dog in this case. Oops, I have to put in a closed parenthesis. So there we go. So dog, and then it says that's not an int, which is correct. It didn't crash, which is good. But this is not quite good enough yet, because in the NumberGuess project, if you type in something like dog, it should say, that can't be an int, not crash. But then it should do it again. Okay, it should ask again. It should go through this process again. So what do you call that when you make something happen again? That's called iteration, right? Which means either a for loop or a while loop. Well, let's see. In this case, I guess it's impossible to predict initially how many times you'll have to ask the user to input an integer. Maybe they'll go dog, and then cat, and then aardvark, and the giraffe. Who knows how long they'll go, right? So what kind of loop is that that's like indeterminate? That you don't know how many times you might have to actually loop. Wow, this is a while loop. This is a while loop. Now, there are 2 ways to go about this with a while loop. One is to have while and then some Boolean expression here that will be evaluated every time that would be how you get out of the while loop. I think it's better in this case just to simply do while true. And again, which of course means that I now need to indent all the code underneath, so it's now the body of the while loop. And again, the way while true works is that, well, every time Python hits line 2, it asks, what's the value of the Boolean expression after while? And it sees true, and it goes, well, true is true, so of course I need to do the loop. So I can't get out of the loop at line number 2, but I can get out of the loop with the return, right? Because remember what return does. Return ends that call to the function. No matter where you happen to be in the function, are you in some loop? Doesn't matter. The function is complete. So if I actually get something that can be converted into an int, I do convert it into an int, and then I jump to the else clause, which means that I return that int, and then I'm out of the function. If, however, I type in something that can't be converted to an int, then line number 5 would have thrown an error, which means that line number 7 will be executed, which means that we don't hit return, not the else, but just the accept, which means that we will loop again, which means we'll have to go through the process a second time. So watch. And then at this point, this is a fairly nice function. So I'm going to call get int, and then going to say, like, I don't know, how about this? Like lower bound. Okay, this will be the kind of thing that presumably your code will do. It will call this function and send like the argument lower bound because that's one of the its that you need. And then here we are inside the function. Now at line number 3, we're inside the while true loop. So let's try dog. That's not an it, and then it asks for it again, right? Because we didn't hit the return statement. So how about cat? Still didn't hit the return statement. Now let's type in something that can be converted to an it, which means that line number 5 won't throw an error, wouldn't have thrown an error, which means that we will execute it. So answer will be an ant, and then we'll skip to the else, which is what you do if all of the try can be executed without error, and then we'll return the value of ants, which will be the integer 1, 2, 3. So there you go. That's a nice little function that can be called with any message that you like, lower bound, upper bound, gas, whatever. And will be guaranteed to terminate only when the user has typed in something that can be an integer. Okay, so now you know more Python than you did before. All right, that's enough for today for sure.